Hi everyone and welcome back to your channel FE Civil Exam with Farhad. Mechanics of Materials. We want to draw the or find the moment diagram for a two simple supported beam with a triangular loading of 30 kg per feet. So if we have like a two simple support beam with a distributed load of W increasing, moving from 0 at A to 30 kips at point B, we want to know which of these diagrams stand for the moment diagram for our beam in terms of keep fit. So in order to do so, first of all, we can replace all. If we know if it was like a rectangular loading, the total direct resultant force applied at the center, and that was WL, the resultant force. But now we have half of the loading, so definitely it doesn't apply at the center, so that's 1/3 of L from B, and the load is half of the rectangular one, so that's WL over 2. And if we want to know what are the support that are A and B are, so simply calculate the moment about point A, for example, goes 0. That gives us RB times L. A counterclockwise is a positive direction for our case, minus the resultant force WL over 2 times 2/3 of L from point A, and it just goes a 0, and it just simply gives us RB is W over 1/3 of WL. Summation of force in Y goes 0. It just gives us RA is WL over 6. And that also makes sense because the bigger chunk of the force handles by the reaction at B, because that's closer to the resultant force, so carries the bigger chunk of energy or load. So as soon as we know what RA and RB is, we can replace that with the numeric value of that. So the numeric value of FR is WL over 2, so that's a WL over 2. And if you want to know what the numeric value for that is, simply multiply 30 times 12 over 2. That gives us 6 times 30 is 180 kips. A 120 goes to RB and 60 kips goes to RA. And as soon as we know that, we can draw the shear diagram. So we know for shear diagram, it just goes up the amount of R sub A, which is 60 pounds, is 60 kips, and this is linear or 1 degree. So we have a parabola of second degree. It just goes all the way down to meets the x axis and then go all the way down to a negative 120, then comes up back to 0 by the amount of RB. Somewhere in the middle of the beam with the length of x, it just meets the x equal to y equal to 0. So we want to calculate that x. If to do so, first of all, if we want to calculate the slope of this line, that's the amount times rise over run, that's 30 over 12, that will give us 2.5. And this is 1 degree or linear, and this is the second degree parabola. So if we want to calculate the amount of x, it simply says 60. We want to know what is the length that gives us the reaches us to y equal to 0. So we can jump to the loading diagram. So area under load is just the amount of shear diagram. So 60 minus the area under here, this triangle. The length is x, the height is 2.5 times x, and that's half of that because that's a triangle. So 60 minus half of 2.5 x times x equal to 0, and that simply gives us the x or the location which it meets y equal to 0 is 6.93 feet. As soon as we have x, we can draw the schematic of the moment diagram. So this is our v, this is the schematic of our moment. So there is no moment at a, and the amount of the slope of v is increasing. It just says the amount of moment is increasing. And so the amount of M maximum is equal to area under the shear. So far for our problem, we do know the schematic of our moment diagram is kind of like this figure. So C and D is already removed, so we have to focus our attention on the A or B. So we have to calculate the M maximum to see which of these two are our correct answer. So one is 279, the other was 186. So far we removed the a multiple choice of C and D. So we have two approaches to calculate this problem. The first one is mathematical solution or conventional solution. The other one is the easier one and the drawing method or moment from shear calculation. So let's jump to the solution one first, the mathematic one, and then that's mainly geometry. So uh, for the geometry or math solution, which is our solution one, we can draw the moment diagram for the length of x. So this is the length of x, slope is 2.5, rise is 2.5 times x, resultant force applies as x over 3, and there is a moment of m sub x here, summation of, we already know RA 60 kips from the previous part, summation of moment about x including mx goes 0, so it simply says the resultant force, which is the area of this triangle, which is a half of 2.5x base times x times the distance x over 3 plus mx, which is at the same direction, minus ra, which is a clockwise, but that's why it's negative, times x equal to 0. We already know what x is, we already know what ra is, so the only unknown in our problem is m sub x, so we can easily get the amount of moment at x, which is 277 keep fit. So our problem is solved with solution one, which is the mathematical one. You can also solve this problem from the moment calculation, which is our solution two, or drawing or moment from shear, which we just moved to that part. So the problem is already solved, but in terms of our solution two, which is drawing, we do know the amount of maximum moment which we are looking for is the area under shear diagram. So if we want to calculate the maximum moment, we just know this is a second degree parabola, and the area of this yellowish area is 2/3 of base times the height, which is 2/3 of 6.93 times 60, which give us 277.2 cubic feet. So that's exactly the amount of M maximum. So if we jump to our uh, choices, you can easily see the closest answer to our M maximum is 277 keep fit. So the reason we didn't get the exact number, if you go with the 4 digit of accuracy, definitely you will get the same number. But in terms of FE and PE exam, you don't need to get the exact value, just get an understanding of the schematic of problem and also the numeric value. Thank you. We'll solve more problems in mechanics of materials in next videos.